All right, guys, we jump into Chapter 6, and we really only do two sections in Chapter 6, 6.5 and 6.6, and we're going to learn how to solve non-right triangles. In case you were wondering, another word for a non-right triangle in math is the word oblique. Okay, so an oblique triangle could be an acute triangle or it could be an obtuse triangle, anything that's not a right triangle. Okay? First thing, what does it mean to solve a triangle? To solve a triangle means to find the lengths of all sides and to find the measures, the measure of all angles. Okay? Now, as you may have guessed, we're not going to give you the lengths of all the sides or the measure of all the angles. We're going to need to do some math. Okay? First things first, when we solve a triangle and when we talk about triangles in trigonometry, there's some certain terminology that we use in terms of capital or lowercase letters, and that's important. So our capital letters represent angles at that vertex. You'll see what I mean when I draw a quick picture here in a second. Our lowercase letters represents the sides across from that angle. Okay? So one of the most basic triangles, and especially when we define the law of sines here momentarily, is just triangle ABC. Okay? Okay? Capital letters for the points and also capital letters for the angles. If we give you A, okay, capital A being something like 58 degrees, that would mean that angle A right here is 58 degrees. Okay? And then our lowercase letters represent the side lengths across from those angles. So little a, lowercase a, would be across from angle A. And lowercase b would be across from capital B or angle B. And little c would be across from capital or angle C. Okay, so if we told you that any of these were certain lengths, that'd be okay. And basically, you need to find 6 things to solve a triangle. Okay, as you will see, we're going to give you 3 things. Okay, we're going to give you 3 of these 6 pieces of information. Your job is going to be able to find the rest. All right. Okay, so now we know what it means to solve a triangle. We got a little tutorial on what capital and lowercase letters mean in terms of angles and sides. How do we solve them? Well, just a reminder, when we were solving right triangles, first thing would be the easy Pythagorean theorem if we were given 2 of the 3 sides. If we were only given 1 of the 3 sides, maybe we thought about our special right triangles, our 30, 60, 90, and the relationships between the sides. That would help us solve for the missing side lengths. Or we use right triangle trigonometry, SOHCAHTOA. Okay? You're going to see that come into play just a little bit here in terms of solving with sine, cosine, and cosine in this chapter, but not using SOHCAHTOA. All right? And then for our oblique triangles, okay, none of these things work for non-right triangles. Pythagorean theorem specifically designed for right triangles. Special right triangles literally says right triangles in it. SOHCAHTOA is right triangle trig. We will not be using these a whole lot. Okay? For non-right triangles, we have laws. We have the law of sines. We have the law of cosines. Technically, there is a law of tangents, but law of sines and cosines can solve any triangles where we would use the law of tangents, so it's really a law that never actually needs to be used. We don't teach it. Neither does our book. Well, let's jump right into law of sines. What is the law of sines? Here it is. little a over sine of a equals little b over sine of b equals little c over sine of c. So we're not, I understand there are two equal signs, but we would only use one of these portions. And really, what we want to say, to generalize this, is that sine of an angle over its opposite side, any triangle, if you take sine of that angle measure over its opposite side, it will be equal to sine of any other angle of a triangle over that one's opposite side. Okay? This is the general version. Okay? If we had angle A and the opposite side from that little a, and then had angle B, but we were looking for little b, we could do that. There'd be one variable in this proportion. Okay? If you guys are seeing something like this and thinking back to Algebra 1, you're going to be thinking about cross-multiplying, things like that. All right, in what cases would we use the law of sines? Okay, we're going to think back in terms of our definition of these cases to how we used to prove triangles congruent in geometry. Okay, so in what cases would we use the law of sines? When you're given the angle-side-angle case or the angle-angle-side case. All right. If you're given two degree measures and the included side, the side in between them, that side length, we should be using law of sines. If you're given two angle measures and the non-included side, we should be using law of sines. More generally, when you're given two angles and one side length. Give you an example of angle side angle here. If this was 84 degrees and this was 39 degrees and this was 11 inches, angle side angle, in the angle side angle case, we want to use law of sines to solve. We'd be able to solve first for one of these two. Okay. In the angle side case, similar diagram. Let's say we were given 84 degrees, 39 degrees, and the 11 inches was over here. We would want to use law of sines. Okay. All right. Let's do a couple examples here of law of sines coming into play. May help to draw a sketch. Let's draw a sketch. I draw pretty much the same sketch every time. Triangle ABC, I don't worry about making it to scale. C is 95 degrees, A is 37 degrees, little c, that's the side length across from C, 18 meters. We have an angle side case. We're going to use law of sines. Okay. This would be little a, there's little b, and we know we need to figure out the angle measure of b. Okay. Easiest thing to do here, guys, is first things first, find capital B, or the measure of angle B. That would just be 180 minus 132. That's going to give me 48 degrees. Or 1/3 of the way home. We found the fourth of our 6 things. Use a different color here. This actually might not be a different color. There we go. Okay. That wasn't using law of sines. Okay. But now we're going to have to. This is not a right triangle. We cannot use Pythagorean Theorem. We can't use special right triangles. We can't use SOHCAHTOA. So we go to law of sines. It states that sine of an angle over its opposite side will equal sine of another angle over its opposite side. Let's put together our proportion here. So we could solve for A or B first using the 95 degree, the 18 as its opposite side, and then one of these two angles. So let's do that. Let's go sine of 95 over 18 is equal to sine of an angle over its opposite side is equal to sine of another angle. Let's pick 48 degrees over its opposite side, lowercase b. We do a little algebra. We cross multiply, we get b times sine of 95 equals 18 times sine of 48. To solve for b, we would divide both sides by sine of 95. And I would put this directly into my calculator, making sure you are in degree mode.